All right, so we're going to go over the other ones. 27. Question 27. The first thing you do, when they give you KSP and they're asking you solubility, it's molar solubility, right? S or X, whatever you want to call it. Doesn't really matter what we call it. Molar solubility. The first thing is look at the number of ions. Notice how that has 4 ions. It's Ag3PO4. So remember the shortcuts. X squared is equal to 2 ions. 4x cubed is equal to 3 ions. And then you have 27x to the 4th is equal to 4 ions, and then 108x to the 5th would be 5 ions. So that's basically what we're using here in this case. So when we take a look here, the first one, if we did a mice table, a mini ice table, we go Ag3PO4, I'm just going to prove it, would break into Ag plus 3 of them, and 1 PO4 3 minus. It's basically you would end up with, and you'd end up with 3x, and x is basically when you drop it all down, it would be 3x and x. Then when we put in our KSP formula, it would be, this would have to be cubed, and that would be to the first. So when I drop it in there, I get 3x, x right there. And so what am I going to end up with? 27, 3 cubed is 27. X to the 3rd, add the extra 4th on there, I get 27x to the 4th. So I just dropped the KSP 1.8 times 10 to the negative 18th down there. And then all I'm going to do is do 1.8 times 10 to the negative 18th divided by 27. And then what I'm going to do is I'm going to take the, I'm going to take the 4 root of it. So I'm going to go second function root 4, and I end up with, correct answer is going to be 1.6. I get 1.6 times 10 to the negative 5th is what I get right there. That would be my solubility. Now, if they ask me about PO4, that would be the correct answer. If they ask me about Ag, though, I would have to take that 1.6 and multiply by 3. So be careful on the AP exam because they ask you about different ions. Next one, B. CaCO3 is going to break up into Ca2 plus CO3 2 minus. So that's going to give me X at X. So basically X squared is going to be equal to 8.7 times 10 to the negative 9th. So all I'm going to do there is go 8.7 times 10 to the negative 9th. I'm going to just take the square root of that, and I end up with 9.3 times 10 to the negative 5th. And then what I'm going to do is, that would be the concentration, 9.3 times 10 to the negative 5th would be the concentration of Ca2 plus. 9.3 times 10 to the negative 5th would be the concentration of CO3 2 minus as well. Last one is a weird ion. Hg2 2 plus is actually a single ion. It's kind of a weird one. So if you take a look, it's one of the only ions that occurs diatomic with mercury, the charge. So what I'm going to end up with is 3 ions. So that means I'm 4x cubed is equal to 1.1 times 10 to the negative 18th. So, well, then my first go-to move is 1.1 times 10 to the negative 18th divided by 4. And then what I'm going to do is I'm going to take the cube root of that. And ultimately what I end up with when I get the cube root of that is going to be 6.5 times 10 to the negative 7th. Now, just so you know, since it breaks up into Ag2, Cl2, you're going to get Hg2 plus, 2 plus, plus 2 Cl minuses. This would be the concentration of Hg. The concentration of Cl, you would have to multiply times 2. So just keep that in mind, all right? So that was that one. And then next question was 29 you had to do. Molar solubility, the first thing I notice, it's MgOH2. So that means what I'm going to have is I have a total of 3 ions. So 4x cubed is equal to 8.9 times 10 to the negative 12. So the first thing I'm going to do is go 8.9 e 10 to the negative 12. I'm going to divide by 4, and I'm going to get that, and I'm going to take the cube root of it, and I get 1.3 times 10 to the negative 4th. Now, when it talks about molar solubility, right, if he had asked you about Mg, since Mg, you produce 1 Mg and 2 OH minuses, this would be 1.3 times 10 to the negative fourth for this. This would actually be 2.6 times 10 to the negative fourth for that one. So keep that in mind based on the fact with the molar solubilities. Molar solubility is for basically the overall compound, the number of ions in the solution. So this would basically be X and 2X because of the ratio in the formula. This one, Al parentheses OH parentheses 3. I have 4 ions, so what am I going to do? Well, 4 ions is 27x to the fourth. So I just dropped my KSP 2 times 10 to the negative 32nd. So the first thing I'm going to do is I would go 2e negative 32 divided by 27. And then what I'm going to do is I'm going to 4 root that sucker, and I'm going to end up with 5.2 times 10 to the negative 9th. And that would be my X, or my solubility, molarity, whatever you want to call it. Now remember, it breaks up into aluminum 3 plus 3 OH minus ions. So the aluminum would be 5.2 times 10 to the negative 9th. I would have to multiply by that by 3 if they asked specifically the OH, so I would say 1.6 actually times 10 to the negative 8 for that one. They don't particularly ask this in the problem. They're just asking you molar solubility. That's an extra step that the AP exam likes to take.